Okay, guys, I know that I haven't been really making a lot of the videos for you guys in this section. So, lucky for us, there's a practice day. This is basically practice of 6-1 to 6-5. So, I'm gonna do this and explain, and hopefully, whatever questions you might have on homework questions, you will be able to do after this. Alrighty. So, I am going to need a calculator though. Exponentials are not fun without a calculator. So, complete the table to make w of x an exponential function. So the key here, you guys, for exponential, so this is great. The key is when you have an exponential function that you multiply something each time to get the next number, each time. Okay, so 50 times something equals 40. So the way we find out times what is we take the second number and we divide it by the first number and we get the thing that we multiply each time. So we do 50 divided by 40. Oh wait, sorry, I said second number. We do 40 divided by 50 and we get 0.8. That means we're multiplying 0.8 every time to get the next number. So 0.8 times 40 should be 32. And 0.8 times 32 will be the next number that I need for this to be exponential, which is 25.6 right here. Okay, now they want me to write an exponential function. So let's understand that, okay? These types of exponential functions, they have this form right here. Y equals AB to the power of x. And A is our starting amount. In this case, it's 50. That's what we started with. And then B is our growth rate, or in this case, we're decaying, our decay rate. But basically, it's our rate. It's the thing that we multiply each time. It's this 0.8. So here comes the exponential function for w of x. W of x equals 50 times 0.8 to the power of x. That's it. Easy peasy. Okay, now let's go do something else. A library ran an ad campaign. The function blah 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 models a number of library members X months since the campaign. Very realistic. It looks like we do have growth because this number right here, the one that has the exponent, is more than 1. However, it's barely more than 1, so we have very slow growth, okay? This number, 1 plus this, our percentage rate, is the number that we're looking at, 1.025. So you got to remember, when our rate is a percentage, if it's growth, the number, the B, the A, B to the X, the B is 1 plus the percent. The percentage is already built in with 1 added to it, which means the library members are growing at a rate of 0.025. Okay, that's the number that was added to 1 to make this number, was this. And then as a percentage, if I want to understand how much this is growing by, I have to move the decimal twice to the right to turn this back into a percent. Because remember, when we have a percentage, we grab the decimal and we move it twice to the left. Well, now we want to get our percentage back. So we move the decimal twice to the right. And we get that this library here situation is growing by 2.5%, okay, each month. Okay, now I went into explaining all of this just because I wanted you guys to understand the formula, and the 3,500 is how many members they started with. However, it turned out that I did answer the question A. By what percent is the number of members changing each month? It's growing by 2.5%, okay? That's how you get that. Write a function a of x that represents a number of members decreasing by 4.1% every month from the same starting value. So that's if this campaign, maybe this is what was happening before they ran this campaign, okay? They were decreasing. So if I'm decreasing, then I need 1 minus my percentage rate, okay? Which in this case would be 1 minus, okay, we got to grab this decimal and move it 2 spaces to the left and put a 0 in its place. So this is 0.041, okay? And that's going to give me my rate, which is going to be 95.9, 0.959. Okay, I just thought I'd double check before I went live with this one. That is the new b value. So we have y, which is a of x, equals a, which is our starting amount, which will be the same as before, I assume, times b, which is our decreasing, so it's less than 1 rate, to the x. Okay, yes, these equations are not so scary. Okay, they tend to be understandable, I would say. And given how calculator heavy this section is, I think it kind of takes a lot of the stress off of the calculations as well. So I know exponents look a little scary. Don't be scared of them. Okay. All right, let's look at card number 3. Here's a function r of x equals 3 to the x plus 1 plus 2. Okay, so before I get into this question right here, I just want to give you guys a quick rundown, maybe like a lesson on this stuff. So when we are looking at something like this function, immediately in my mind, I'm thinking about that parent function. The parent function for exponentials, it's going to look a little different each time. It's going to be the b, whatever the b value is, in this case 3, to the x. That's it, okay? And there's really only 2 things you need to know about this, all right? About the parent function of these. Here, let's do one step earlier here. Y equals b to the x, parent function. You have like 3 points, okay? There's always going to be 0, 1 on the point, because if you plug 0 in for x, it doesn't matter what b is, it comes out to be 1, okay? Then if you plug 1 in for x, anything to the first power is itself. So 1 comma b is also always a point. And then the next one, you could do like 2 comma b squared, or what I like also a little bit is a negative 1 comma 1 over b. These are points that these b to the x's always follow. So when you put a negative 1 in for x, you would get b to the negative 1, which, remember, tells you the negative exponent just tells you to flip the base, okay? These points are always on the parent function, all right? And then the next thing I want you guys to know and understand is that when b is bigger than 1, we start low and end high because we're growing. So this is what it looks like when b is greater than 1. It's that general shape with an asymptote at y equals 0, all right? Whenever we have b less than 1, Then we have decay, which means that we start high and end low. Like that. Start high and end low. But we still have a horizontal asymptote at 0. My horizontal asymptote will remain at 0. It's not going to change, not unless I have a vertical shift. Unless I shift up or down, then the asymptote will also shift up and down. But unless there's a vertical shift, then I still have my asymptote at 0. Okay, so this was a parent function lesson. Let's go apply it to our specific parent function for this problem, which is 3 to the x. Okay, remember b to the x, b is 3 this time. So watch how I use these points. Okay, thank you. A 0, 1, and then 1 comma b, and b is 3. So 1 comma 3. And then I could do 2 comma b squared, but b squared is 9. I'm not loving it. However, I could also do negative 1, 1 over b, which is 1 over 3, which is right here. And then you can see the start low and end high shape of a b greater than 1, just like we expected it to be. And it looks like that, with the asymptote at y equals 0. Okay, this is your lesson on graphing exponentials. So let's come over here now and see what they're asking me. And hopefully my explanation of everything I just gave is enough to answer all these questions. What's the horizontal asymptote? Great question. I know that it starts out at y equals 0, and then it moves if there's a vertical translation, shift translation. Which in my situation, I have got myself this happening. That's too big. Why is that so big? I've got myself this right here happening. I also have this right here happening. This is a horizontal shift, horizontal translation. Left one, because x is a liar. And this guy is a vertical translation up to, because y doesn't lie. So I did have a vertical translation, which means my asymptote has gone to whatever this is, whatever the vertical translation is. So instead of 0, it's 2. All right, it's that easy. So asymptote is at 0, moves if there's a shift, and where does it move to? It moves to wherever the shift is, okay? All right. It wants to talk to me about the y-intercept. Okay, well, the y-intercept of the parent function was 0, 1, remember? We said every one of them 0, 1, because when you plug 0 in, anything to the 0 is 1. But we've got some shifts happening, so things are a little different now, all right? If I want the y-intercept here, I personally think the easiest way to do it, remember that a y-intercept occurs when x equals 0. So if you just find r of 0, you'll get the y-intercept. Let's go plug 0 in. We get 3 to the 0 plus 1 plus 2. So this is 3 to the first power plus 2, which is 5. So the y-intercept is 0, 5. Okay, the x value is 0, the y value we found is 5. Okay, is it increasing or decreasing? Well, I know that the parent function is increasing because it's growth. Now, if it flips anywhere, that might change. However, I had no flips, okay? So a base that's bigger than 1 is growth. But then if you do a flip and it becomes upside down, or even if you do a flip to the left, any flip will change the increasing to decreasing. But we had no flips. We had translations, but no flips. So because the base is bigger than 1, the base is the only thing really to worry about here, and our function is absolutely increasing. And now they want me to sketch it. I already have a beautiful sketch of my parent function. All I got to do is move it left 1 and up 2. So there was a point at 0, 1. I have to move this left 1 and up 2. There was a point at -1, 1/3. I have to move that left 1 and up 2. And then there was a point at 1, 3. But I'm going to move it left 1 and up 2 to get the same shape as that over here. Now there's one more thing I got to move. I got to move the asymptote, because if you, I can say, oh, they might not be a very good artist. I can excuse some stuff. What I cannot excuse is you drawing your graph crossing the asymptote. So the asymptote was at 0, but I also have to move that left and up 2. Now when it moved to the left, it didn't matter because it's already going all the way left and all the way right. But the up 2 part was important. And you better make sure, you guys, you draw me your curve. Make sure it has that shape. Make sure it doesn't cross the asymptote. Okay? Asymptote at y equals 2, just as we said earlier. Okay, very good. Okay, you guys, I hope that was a very thorough explanation since I didn't do the homework video of that. Okay, here we go now. Now we have a function, yada, 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 yada. But this is what I notice about it. I notice that it has a vertical shift. It's not a plain old AB to the x like the previous word problem we did. This is that temperature problem we looked at. The temperature of cocoa is served at 140 degrees Fahrenheit, where x is the number of minutes after the cocoa is served. What could the horizontal asymptote mean in this situation? So in this situation, you guys, if you could remember that how it was, we had ourselves coffee, but right now it's cocoa. That's poured, and it's poured like hecka hot. And then the temperature decreases as time goes on. I kind of drew this bad, but that's okay, because a negative doesn't really matter, right? We're not pouring in negative time. So let me draw it more like curved like that. So the cocoa gets poured at a hot temperature, and then it starts cooling down immediately. And then it approaches this horizontal asymptote. In this case, it's at y equals 50, because that was this number right here. Remember that the vertical shift is your asymptote. So what does it mean? Well, that means that my cocoa is not going to go below 50 degrees. Why won't it go below 50 degrees? Probably because that's the temperature of the room that I'm in, okay? It's a very cold room, but we tend to have hot cocoa when it's cold, so I guess that kind of makes sense. What does it represent? I would say the room temperature. Or maybe we're outside and it's 50 degrees outside. So outside temperature, just the temperature of wherever the cocoa was poured. I think it makes more sense to be outside. Okay, fill in the blanks to write an equation k of x that represents the temperature of cocoa that is served at 160. Okay, so please remember, this 140 was us adding the 90 plus the 50. 90 plus the 50 made the 140. So now I want it to be 160. Okay, so I can mess with it, right? I can say, okay, either we're in an actual room now, so that's 70 right there and 90 right here. 90 and 70 makes 160. That would work. Or you can say we're still outside and it's 50 degrees, but we're just pouring the cocoa at a much hotter temperature. So 110. Sorry, I forgot what this number was. That's it. Okay, as long as you write whatever number here and whatever number here to add up to one another to make 160, you're good. Okay, so you can even get creative with it and do something different than what I did. Okay, let's go look at card number 5. The function yada yada 5e to the 0.105t represents the surface area of a countertop that's covered by mold after t hours. That's gross. Okay, complete the statement. The area covered by mold is growing by blank percent compounded blank. Okay, so we know, you guys, these equations, when they have E in them, E is our constant for continuous growth. So we're compounding continuously, okay? And then the growth rate is this guy, the 0.105. That's my growth percentage, except that really to be a percentage, I need to move this 1, 2 over to turn it into a percentage. So 10.5%, because they took 10.5 and moved the decimal twice to the left to get that. All right. How much of the area is going to be covered by mold after 3 hours? That means I got to let 3 be t. So I go to this exact formula. I'm calculating S of 3. And this can go in my calculator in one shot, watch. So 5, you find your e to the x, which is second that ln button. And then you put in the 0.105 times 3. And it's 6.85. How much of the area? 6.85 square centimeters. Okay? Or centimeters squared, whatever, however way you want to write it. You could even write out all of that. It's fine. Okay, next. Luis deposited $250 into a high-yield savings account that earns that much interest compounded monthly. Let's write an equation. So, I gave you guys the equation for this, all right? It was the A equals P times 1 plus R over N to the NT, okay? Where A is our ending amount, P is our starting amount, R is our rate. It's going to be a percentage, so we got to move the decimal twice to the left. N is how many compounds in a year? That's the same N right there. And T is time. Okay. So if we write this equation, D of T, it's going to be our starting amount, which is 250, times 1 plus the rate, which is 0.0375 because I moved the decimal over twice, divided by the number of compounds in a year. So how many months in a year? N is 12. And then we raise it to the 12, and again, times t. T. That's it. That's the equation. And for part B, where they want to know how many after 10, then we're finding d of 10. So the 250 times 1 plus 0.3, oops, 03, ooh, not legible anymore, divided by 12 to the 12 times 10. Now you guys, be careful, okay? This 1 is not part of this fraction. Don't you mix them. Don't add these first and then divide, all right? So just be super careful about these little places where mistakes occur. And if you're very careful, your calculator can do this for you in one shot. You just have to tell it 250 times 1 plus 0.0375 divided by 12. Close the parentheses. Hit that little caret button, raise it to the power of. Now, because we have 12 times 10, we need to put the 12 times 10 in parentheses. 12 times 10. And now if I press enter, that's exactly how much money is in that account after 10 years. $363.54. With the units, which is the dollar sign. Okay? All right, let's keep it going. Card number 7. It looks like they're taking us back to card number 1 stuff. All right, so let's see if you guys can figure this out without my help. Do you guys remember? Please pause it and try. Otherwise, if you're watching the videos and what I explained in card number 1, you're still unsure of how to do card number 7, it wouldn't be helpful for me to explain card number 7 to you. It would be better for you to go back to card number 1, rewatch, relearn, come back, try card 7 for yourself. All right? What I will do is give you the answers without explanation, because I don't want to make you guys dependent on my explanations. I want you to be independent. Okay. Sorry, I got distracted on the calculator. Here we are. The number here, if you did it correctly, you should get 92.61. And the equation, 80 times 1.05 to the x. Okay. Let's move it along to the next one. An aquarium has a population of 5,000 fish. Write a function that can represent the increase. Okay, this is a little different than ones we've done before, even though I still want to challenge you to pause this, okay, and go back and try card number. Look at the explanation for card number 2. All right, hopefully you can come up with card number 8 on your own. All right, so pause it, go do that. Please do that for yourself, okay? Otherwise, I am going to do this and explain it quickly. However, I do hope that you can figure it out. An aquarium has a population of 5,000 fish. This is my starting amount. They want me to write a function that can represent if we're increasing. Remember, increasing means 1 plus whatever percentage rate they're about to throw at me. The decimal has to move twice to the left, so it's 0.075. Okay, and the function that they want, I'm ready, let's go. It's f of x equals the starting amount times b to the x. That's it. Okay, let's write a function g of x that represents it decreasing. So now 1 minus whatever the percentage rate, same one. And that's it. So we write g of x equals that same starting amount, but now it is 1 minus the 7.5%. All right, so it's 92.5% to the x. That's it. All right, when it's increase, 1 plus the percentage. When it's decrease, 1 minus the percentage. Okay, card number 9. Ooh, it's that cocoa sitch, except now we're looking at popsicles. So things will be different, all right? The cocoa was poured at a hot temperature and it cooled off. These popsicles start at a cold temperature and they heat up, all right? We're still going to be approaching this asymptote of whatever that number is. So that part is not different. Except now we're increasing. Now we have a reflection of the old graph, which explains, here's the old graph right there if you can see it. It's flipped for this one, which explains that their formula is negative, all right? Okay, so it represents popsicles served at -4 degrees, X minutes after. What could the horizontal asymptote mean in this situation? Okay, so yeah, in this one, we are either outside and it's 89 degrees, all right? It is an 89-degree day. Or, you know what this could be? This could be my classroom during 5th period. 5th period. Inside. All right, sorry, I couldn't help myself. Let's move on. Okay. Fill in the blanks to write the equation so that it represents the popsicle being served at 5 degrees. So this part is not different, you guys. The temperature, the original temperature is still this plus this. All right, so this plus this is -4. Now we need to come up with two numbers that when added together, they make a +5, okay? So how about we do easy ones like -95 right there. And then we do 100 right there. Because -95 plus 100 is 5, all right? But you could do whatever you want. I don't know. Do you want to do -90 and +95? It's 95 degrees outside. Do you not want it to be 95 degrees? You want it to be 80 degrees outside? That's fine too. Then you need a -75 here. Okay, either way, just make it so you add these two and you get that number. Okay? Okay, here we are. Here's a new function. And we're going to do just what we did over here. So again, please go back to the explanation of card number 3. I'm not going to go through that much explanation again. I hope I don't have to go through really much explanation at all, that you can do this on your own. I have the same parent function of 3 to the x, except now I've got a horizontal reflection. And I've also got a vertical translation. So this is all the stuff that I'm thinking right off the bat, you guys. I'm thinking that I'm going to have to flip it and move it down 9. But in addition to that, I'm thinking that I'm no longer going to be increasing now that there's a reflection, okay? Because remember that the parent function looked like that. So I'm not expecting mine to increase anymore because there's a reflection. I'm also expecting my asymptote to be at -9 because I noticed that there's a vertical shift. All of these little thoughts are in my head, okay? And let's keep going now. Oh, what's the horizontal asymptote? I am ready for this one. It's my vertical shift with a y equals in front of it. What's the y-intercept? Okay, that's still going to be x equals 0, all right? So I'm still going to go with j of 0 equals 3 to the negative 0, which is 0, minus 9. 3 to the 0 is 1, you guys. Don't rush and call that a 0 or a 3. It's neither of those things. It's 1. Minus 9, negative 8. My y-intercept is at 0, negative 8. Is the function increasing or decreasing? Well, I am willing to bet it is decreasing. However, because it was increasing and then I flipped it, all right? However, you guys, after we sketch, let's go back and see all of these things in action with a sketch. Because when I was a student, I overlooked things when I just did the algebra. But if I did a sketch and I looked at the sketch, I caught my mistakes. So always look back at your sketch and make sure everything that you expected adds up. Okay, I'm going to start with the parent. I'll graph it in green. So remember, the parent function has 0, 1. It has 1b. It has negative 1, 1 over b. So this is my 1/3, negative 1, 1/3, 0, 1, 1, 3. I can actually even do 2, 9 because this graph has all that going on. This is the parent function with an asymptote at y equals 0. There it is, okay? And now I have to do a horizontal reflection and a shift down 9. Sorry, I have a bad memory, so I just have to go back and make sure. Yeah, horizontal reflection and down 9. So let's do it with this yellow real quick. My horizontal reflection, everything will flip left, right, okay? This guy stays right there. If it's on the y-axis, it'll stay there. But this one that was 1 away to the right will go 1 away to the left. And this one that was 2 away to the right will go 2 away to the left. And then this point right here will go the opposite way as well. And so here is that graph after the horizontal reflection. And now all I got to do is move it down 9. Move all my yellow down 9. So down 9. This guy is up 3. Down 9. That guy is up 9. So down 9. And that guy down 9. And remember, don't forget, you also have to move your asymptote. Down 9. Wait, have I moved down 10? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh no, I just messed this last point up. That's the only one. And the asymptote I messed up. Everybody else did move down 9, but these two, this one and the asymptote, I moved down 10. So down 9 would actually be right there. Okay. There's the final graph right there. Okay. So let's go make sure this is a y equals negative 9. Let's go see. Yep, that's the asymptote I got. That's the y-intercept I got. And is this function decreasing, you guys? If you're standing on the left side of this graph and you're hiking, are you going downhill? Yes, you are. Okay, so yes, it is decreasing. Always the left side. You always look left to right. Okay. Okay, here we are, back at it. We've got algae now, okay? So we've got algae in a lake. Same situation, you guys. E is continuous growth. And in this case, the growth is by 8 8.5%. All right, move the decimal over twice to the right. So the algae is growing by 8.5%. You guys, with these E equations, if it was decay, the rate would be negative. It would be negative 0.085, okay? So just with the E ones, E to the negative, whatever the rate is, means decay and or decrease, and E to the positive R means growth or increase. All right, so just remember that. In our other equations, we don't see that negative because it becomes 1 minus the percentage and it ends up being a number less than 1. Only when it's E, it shows up this way. So please remember that. I'm gonna do a big so if you're just scrolling through this video, hopefully you notice that this was something important I said over here. It's an 8.5% compounded continuously. That's what E is. And how much after 5 days? Just plug in 5. 72 e to the 0.085 times 5. 72 times, okay, we gotta go e to the x, so second ln, 0.085 times 5. Enter. 110. 0.13. Square meters. So you can say meters squared. You could write out, oh, you can't see. You can write out square meters. Same thing. All right, but this is what I put in the calculator. Oh my gosh, we're at the last one, you guys. Caleb charged $800 to a credit card. It has a 19.25% rate, compounded daily. Write an equation for CFT that represents the credit card balance T years if no additional payments or charges are made. So again, you guys can use the formula. Okay. Where all the stuff stands for all the stuff that I explained in card number 6. Okay, so you can go back and look at that if you need. Okay, CFT is going to be the starting amount, which is 800, times 1 plus, so you guys, I'm rushing it because I did this already, 0.1925, that's my rate with the decimal moved over twice, divided by n being how many compounds in 1 year. If it's daily, that's 365 in a year. And then raised to the 365 t. That's the equation. And then if they want to know what it is after 3 years, gosh, I'm so scared for Caleb. That $800 he spent, how much is it going to cost him? Okay. 800 times 1 plus 0.1925 divided by 365 to the power of parentheses 365 times 3 close parentheses. Enter. 14.25 and 5 cents. Ouch. Dang, he could have gotten almost 2 of those things, or bought something else for $600. Yeah, credit cards are bad, guys. All right, that's it, you guys. Man, did we do a lot. Did we learn a lot here? This was a pretty decent review of all things 6.1 to 6.5. Good luck, you guys.